Steve, Majority is speaking about C# 10.
All right, great. And I'm assuming everyone can see my screen. If not, give a yell. Yeah, if everyone can mute, that would be great. I will keep an eye on the chat. So you can either send a chat or do the hand raise feature in Teams, and you can come off mute with a question. Don't be shy of interrupting me anytime. We're going to talk about C# 10 tonight. And I guess I should mention that my team at Microsoft is hiring right now. So if you're interested, there's my contact information right there. Feel free to send me a message and I can tell you more about it. But tonight we're going to talk about C# 10, and we're going to talk about the new language features. Now, every time I give a talk on C#, whether that's 8 or 9 or 10 or whatever the case may be, I always like to start with a little history lesson because I think the context of knowing we're at 20 years now of C#, which is just crazy to think about it, especially for an old guy like myself that's been doing this since C# 1. And I think it's important to know the history lesson because a lot of the features that came before set the context for a lot of the features that you see come in even today. So even back in 2002, when we had C# 1, that corresponded to .NET Framework 1 and 1.1, right out of the gate, C# was a pretty robust programming language, full inheritance, abstract classes, interfaces, and you could be really productive with it right out of the gate. Then in 2005, we had C# 2 come out. And in C# 2, that corresponded to .NET Framework 2. And there was a bunch of features that were added to C# 2, like static classes and iterators. But without a question, what I call headlining feature was generics. And generics enable us to do things in a type-safe way that really wasn't possible in C# 1. Then fast forward 2 years to 2007, C# 3, which corresponded to .NET Framework version 3.5. And again, we had probably a dozen new features like lambdas and extension methods and anonymous types and types inference. And all these features were pretty cool and stood on their own. But without question, the headlining feature of C# 3 was link. And a lot of those features I just named, although they were headlining features, a lot of them were there so they could work together to create this elegant implementation for what we call link, which is still very popular today. And then in C# 4, we had only about 4 features that came out with C# 4, like named and optional parameters, some COM enhancements, covariance, contravariance, probably you didn't even notice that came into the language, because the headlining feature of C# 4 was dynamic. The dynamic keyword was introduced. The running joke was enabled you to statically type something as dynamic and relax some of the compile time static type checking rules that C# would have. Then in C# 5, there was only about 2 or 3 new features. Again, the headlining feature was async and await. And it was the thing that enabled us to very easily reason about the code. So asynchronous code that a lot of times mentally we're jumping all around the place. Async and await allowed us to reason about that code in a much more sequential way the way our human brains think of it. And that was so influential that a lot of the things you see today with TypeScript and ECMAScript with async and await was the ideas and concepts originated from back in 2012 from C#. And then TypeScript came, and then now even ECMAScript incorporating some of those things. Now, what you might have noticed on each of those versions I just said was, yeah, there was a bunch of features added to each language, but in each time there was sort of this headlining feature that got all the attention. But then that changed a little bit in C# 6 in 2015, because in C# 6, there was no real big headlining feature. There was a bunch of little useful features like string interpolation and auto property initializers and expression body members and things like that. I guess if there was a headlining feature, it was probably Roslyn, but that really wasn't a language feature. That was a feature of C#, which is like a compiler in the box. But the language features, it got to the point where C# was getting really mature at this point, 13 years old, and a lot of the features that were being added were nice to have. Sometimes, in some cases, things that were being added where you would have thought we would have already had them, but just making it more finished. C# 6. Oh, actually, that's what I just mentioned. C# 6, C# 7. I'm got to keep it straight here. I would say that if there was one headlining feature, it was probably tuples, not a life-changing feature by any stretch like generics or link. But there are some other interesting features added there, like deconstructors, not to be confused with destructors, local functions, pattern matching, things like that, digit separators. And then there's these point releases that happen in C# 7, point 1, point 2, and point 3, that if you weren't paying really close attention, you may have missed completely. And a lot of these were just kind of nice to haves, although there were some really nice things in there, like an async main function in console app, inferred tuple names, private protected. Again, just giving some finishing touches to things you would have maybe expected to already be there. C# 8, I would say there was probably about 8 or 9 features that came in with C# 8. More pattern matching, indices and ranges, static local functions. Again, some nice to haves. The headlining feature there was probably nullable reference types. And then in C# 9, similar thing. The one headlining features there was records. But we also had some other things like target type new expressions and more pattern matching enhancements and that sort of thing. So here we are now today with C# 10, which came out a few months back. And I think the way I think about C# 10 is there's not one singular headlining feature that sort of defines the C# 10. And so some of the things that we're going to talk about today are really just nice to have. They're not things that you're going to use every single day in your daily job. Maybe a couple of them you will. But some of them are just, you'll probably find yourself a couple times saying, wait, that didn't work in before C# 10. And so that's a lot of the things the language designers are really thinking about, is things that maybe frustrated people before about why isn't this working? Some of those scenarios now will just work. So with that, these are the features that we are going to cover today. So these 12 features, I'm going to show demos for each of these. Don't worry about memorizing this list right here. And actually, there was probably about 16 or 17 features added to C# 10, 12 of which that you see right here, I'm actually going to demo. So with that, let's put an end to PowerPoint, and I'm going to spend the rest of the time actually just in Visual Studio. So we're going to come in here, and I've got the latest version of Visual Studio. And actually the other thing I'm going to do is I'm going to turn off my camera, because I've noticed that sometimes the camera makes my machine run a little bit slower. So I'm going to create a new console app right here. I'm just going to say next, and we're going to call this CS10, C# 10 demo. We're just going to put that right in there, and we're going to make sure that we create the latest version, which is .NET 6. And I think everyone's muted. Again, feel free to raise your hand or come off mute if any questions come up as we go. So we're just getting the file new project experience here, and hopefully I turned my camera off in time, so this can run a little bit quicker. But here we go. You can see that we have console write line hello. And when we first look at the code here, you're going to see a little link that says, hey, this explains the file new project templates. You can click that link and see some things here. We don't really need that. Let's get rid of that line of code. And if I do Control F5 and run this, well, we're going to see that it just works. Console.writeLine hello world. And sure enough, when I run it, everything just works. And there is my hello world. And the other thing you're going to notice is that when I look at this code, there's no namespace, there's no using statements, there's no main method. And this is not new in C# 10. Think of this as being more so new in C# 9, where they were trying to get rid of a lot of this ceremony. If you were doing a simple console app, they didn't want to require people to have a main method. Now, there actually is a main method being generated behind the scenes on your behalf by the C# compiler, but you didn't have to write one because they wanted the barrier to entry to be as small as possible. But again, that's not new in C# 10. That was there in C# 9. Okay, so let's jump into a couple of things here. So I'm just going to, in fact, we don't even need this. Well, I'll just leave it there. What the heck? So I'm going to say list of string, and we'll just call it list. And then I'm going to say new. And target type new expression, that is not new. That was new in C# 9. But what you're going to notice is this is compiling, no problem. When I do a build here, we can see that this works. Build succeeded. And you may be looking at this like, why did the build succeed? Don't I need to, didn't Steve need to put a using statement in here for system generics collection, system collection generic? Yet somehow it just magically knows that namespace is there, even though I didn't include it. So how is this magic happening? I'm going to double click the CS proj file here, and you're going to notice that there is this setting in here called implicit usings. I'm going to disable this. And by the way, I'm going to also disable the nullable just because it's not relevant to our demo here. But the implicit usings is the one I really want to focus on. And when I do that, notice I'm getting a red squiggle here. It's no longer happy anymore. Now it's confused, saying, now I don't know where to, in fact, it doesn't know about this console write line either, because it doesn't know about the system namespace. So something about this implicit usings, we'll investigate a little bit more in a second, exactly the detail why. Something about this was letting it know the system namespace should be included in the console, the generics should be included. Let's also create a person.cs class right here. And in this person.cs class, we're just going to add a couple properties here. Actually, you know what? Let's create records. Let's skip the class. We're going to create 2 records. We have a person record. We have an address record. The person record has 3 properties: first name, last name, and address. And address is right down here. And if I were to, for example, add a date only, so like date of birth, for example, and let's get rid of all these namespaces here, you're going to see that similar. It doesn't know how to find the date only. It happens to be in the system namespace, but it's getting confused. It doesn't know how to add those things to it. So what can we do here? There's a couple of ways to remedy this. I'm going to add a new class called globalUsings.cs. And in here, I'm going to just clear all this out. And I'm going to add a bunch of using statements in here. And on the first one, I'm going to add the keyword global. And this is a new feature of C# 10 called a global usings. And by doing that, when I flip back over to the person, notice the error is gone on the date only, because it knows that, okay, it's as if I'm saying there's a using system declaration at the start of every class. In fact, if I go back to program, the console write line is happy now too. No more red squiggle there, because it just knows that that global using, it's like saying, put this using statement at the top of every single file, for example. So I can come in here, and let's do that for all of these. Let's just type global here. We'll use a little multi-cursor. And that includes the collections namespace. So even my generics one is happy now as well. The list of string is happy. So the other thing we can do is if we bring this back, so we can say enable, I'm just trying to illustrate, there's a couple of ways we can do it. If we do implicit usings, we can enable it there, or we can have global usings. Now I'm going to temporarily comment these out, okay? But I'm going to bring back the enable, so everything should still be working. Let's just verify everything's still compiling and everything's still happy, and yes, it is. Now, what I want to do is I want to make sure you kind of realize what is happening behind the scenes here. And even if we declare a person object, person, let me come back to that, person P, and then we'll say new, and let's use a target type new expression, Steve, Nicolati, and then we'll just pass in a null for the address. Notice we're getting a red squiggle for this one because the person.cs is inside of a namespace called CS10demo. So it's getting even confused for this one. Let's comment that out for now, make sure we're building. Okay, now, okay, where were the global usings located before you added global using of CS? So that's exactly what I'm about to describe here. So the question on the chat was, where were these things before you added it? So there's 2 ways to do it. One is global usings, I illustrated that. The other is this mysterious implicit using set to enable. And so I'm in the process right now of illustrating what's happening here. So what I'm going to do is I want to come over here to, this is the directory where I have I did file new project, CS10 demo, my dev directory. I'm going to cd into my CS10 demo obj debug .NET 6 file. And notice that there is this little file that got put in the bowels of my obj directory. You can see obj debug .NET 6. And this file is called cs10demo.globalUsings.g.cs. Okay, and we're like, well, what is that mysterious file? I didn't put it there, right? But that file got put there as a result of this compiler setting right here. I don't want any of this to be magical for you, so I want to dig into exactly what's going on. So what are the namespaces that magically get included there? So let's just cat that file here, cs10 demo. I'm just going to cat that file. What's inside that file? It's this. You can see it's auto-generated, and by default, it includes these, what do we set, about 7 namespaces here. So the generics was there, system was there. When you do enable, those are the 7 that the .NET framework designer said those are the ones we'll put in there. Now let's say we want to control what gets put in there. One option here is we can create an item group in our CS proj file, and we can add a using statement here, and we want to include that CS10 demo one right there. And the other thing is, when we look at this, we might say, well, all right, I use the system threading tasks a lot. Every time I need to use async and await, I use that, but I don't really need system threading. There's no point in wasting that. So we can come in over here and say using remove, and this will be system thread. Okay, so let's build that. So now a couple things. Let's go back here. Let's uncomment this. No more. Let's see. Oh, it's not happy with my because I date of birth. So let's get rid of this because that was just something I added because I wanted to show you that example. Get rid of that parameter. And now we have no more compiler error here because now it knows how to find that person object, that record, which was in the CS10 namespace here, because I included it here. Let's just make sure everything is building. Yes, it is. When we come back here, let's cat it again. And a couple things to notice. What changed? Number one, this is now included. That was not in there before. And previously, we had system threading in there, and that's nowhere to be found right here because I removed it. So you have full control over the auto-generated things that get included. Now, having said that, the next logical question that always comes up is, okay, well, there's multiple ways to do things. What's the best way to do it? Should I control everything in here? Should I control everything in here? Either is perfectly valid, and the answer is it's personal preference. Personally, I like to control things in .cs files, and so that's my personal preference. Your personal preference might be different, and that's great, but it is truly just a personal preference. And by the way, you could say, oh, well, this has compiler support right here because it's in the C#, CS class. But even in here, if I put something invalid, like let's say I say XXX, if I try to run it, it's going to say, no, I don't recognize that namespace. So even in the XML file here, it's still going to give you solid validation. But again, personal preference there. Okay, so let's keep driving forward. That was global usings. Another thing you're going to see here is as I go through this, I'm going to put these comments all over the code. So I'll make all the code samples freely downloadable. I'll post a tweet out on Twitter with a download link, and I'm not going to delete any code. So as I go through, I may move some code off to the side, but I won't delete it because I want anyone that downloads the code samples to be able to come in and recreate the demo. Okay, so let's go back to that person class. Now, when we look at this namespace declaration here, you're going to see that there's a lot of white space here. We have a namespace declaration and curly brace, and look at all this indentation we had to do. I was watching a presentation a few months back with the C# language designers, and they said, when we go back and think back over 20 years of C# code, they're trying to estimate the number of terabytes of white space that's been checked into source-controlled systems all throughout the world just because they forced everyone to have this indentation. A lot of other programming languages don't force you to do that. And wouldn't it be nice if you didn't have to just very second line of code, you have to start indenting things all over the place. Now, you don't have to. Watch what happens. I'm going to just put a semicolon at the end of line number 1. And notice what happened. The curly braces went away, and the indentation went away. Let me do that again. So here's the normal declaration. You have indentation here. You have a bunch of white space here. And if I put a semicolon here, the Visual Studio editor is just going to say, oh, now we no more white space, no more indentation. Everything is going to run the same because this is a new feature of C#10 called file scoped namespace. So you're just saying, hey, anything in this file is going to go in this namespace, and you don't have to indent it. Personally, I love this feature, and this is coming from a crusty C# developer that's been doing this 20 years and indenting his code for 20 years. I like this feature because a lot of other languages like Python and different languages, they don't force you to do all this indenting right out of the gate, first line of code. If you don't like the feature, don't use it. Again, this is one of those personal preference things. I personally do like this feature, so that is something you kind of make that decision on your own, so to speak. Okay, let's keep driving forward here. So let's do a few more examples. So next thing is I'm going to put a constant string on here, and let's call this greeting. I'm just going to say hello. And on the next line of code, we're going to say message, and we're going to do some string interpolation here. So I know it's string interpolation because I have the $sign there. And string interpolation was added in C#6. So we'll say greeting Steve. And then let's just output the message. Let's just run it to make sure that the greeting Steve is going to result in hello Steve, as we thought right here. Now, some of you may be looking at this example like, okay, what's interesting about this? But this is actually a brand new feature of C#10, which is constant interpolated string. And this literally does not compile in C#9. And the reason was because if you look at this code, there's actually some string concatenation going on here, and this is a variable. And traditionally with constants in C#, everything must be constants. But in this case, because it realizes that greeting itself is a constant, and this is also a constant, this is now allowed in C#10. So it was this is a good example of a feature that before C#10, if you try to do this, you may have been scratching your head a little bit. Well, why can't I do this? I should be able to do this. And you're right, you should have been able to do it, but you couldn't. So in C#10, the language designers fixed that issue, and now you no longer have that issue. Now, again, remember the rules. Both of those have to be constant in order for this to work. But again, just to prove it to you, if I come in here and make the target framework, .NET 5, so we're doing this in C#9, it won't be happy with us, because then when we try, you can see I'm getting my red squiggles right there, like, no, this does not work. And that's why, because that's not supported in previous versions of the language. There you go. I've just proven it to you. Okay, so that is C#10 constant interpolated string. Now we're going to start to deep dive a little bit on string interpolation, because there are some interesting features that were added in C#10. And so buckle up for this next 10 minutes or so, because I really want to deep dive. I don't like to just show you the features. I like to show you the features and peel back the layers to also show you what's going on behind the scenes. So we're going to do a few lines of code here, and I put a couple of log messages out. Nothing too interesting about these. Some cool log message on this date at this time, and some cool log message in this year at this time. Okay, and if we run this, output is going to be exactly as we expect, at this date and this time, at this year, at this time. Okay, and this is string interpolation that we would have been able to do in C#6. And the not really dirty little secret, but the not very well kept secret is that from C#6 on, when you did a string interpolation operation like this, it was actually using string.format behind the scenes. So for example, if I change line 13, instead of using var, if I change this to formatable string, and let's change this to right here, MSG1, a formatable string actually has a format and an argument count. Let me show you exactly what I mean by that. So if I come in here, you can see that my cool log message up here on curly brace 0 at curly brace 1 and a period at the end, argument count is 2, because 1, 2. I don't know about you, but when I look at that statement, that sure looks like a string.format to me. And so that's the string interpolation behind the scenes using string.format. Okay. Now that's all well and good, but let's again take a closer look behind the scenes here. So if I look at this, what we can actually see happening here, and actually I'm going to do one other thing. I want to talk about previous version of the language. I'm going to very quickly add a new project to my solution here. This is also going to be a console app. We're going to call it C#9 demo. And for this one, we're going to set it to .NET 5, not .NET 6, because I want to show this example in the context of C#9, so you can understand the difference between C#9 and C#10. And let's just do a quick build right here. And I'm going to right-click my method here, and I'm going to open an ILSpy. So ILSpy is the thing that will decompile the code that the C# compiler has generated on your behalf, kind of like reflector is what we used to use back in the old school days. Now we can just use these tools like ILSpy. And I'm going to select this older version of C#. I'm going to say, show me what this would have looked like in C#5 before we had string interpolation. Because if I do something like C#6 or beyond, it's just going to say, oh yeah, well, it's string interpolation. There's my $sign, string interpolation. So I'm going to select C#5, really old, so that we don't have string interpolation. And look at what you see here. The first line is just doing straight up string concatenation. There's a plus, there's a plus, there's a plus. Even the plus at the end for the period. But the second line is using string.format. And you can see the 0 and the 1 there, and then the arguments being passed in. So the one question, and again, even before we get to C#10, is like, well, why is one doing straight up string concatenation and the other one's doing string.format? And the answer is because in the line number 6 for MSG1, the variables are all strings. This is a string. This is a string. However, on line number 7 for MSG2, this is an integer right here. This may be a string over here, but the year is an integer. So when you don't have everything that's string, then the framework defaults to string.format instead of straight up string concatenation. Okay, and by the way, string.format internally uses string builder, just as an FYI. Okay, so having said that, let's now flip back to C#10 so we can understand what's going on behind the scenes in C#10. Now, these are the exact, we agree, these are the exact same lines of code I just showed you on the C#, previous or C#9. So now, once again, let's close this down, and I'm going to once again open this in ILSpy, but now I'm opening the C#10 version in ILSpy, and let's see what the differences are and what the compiler generated. Because the C# compiler is just generating IL code, which will eventually get converted to machine code. Now here in C#10, you see no references to direct string concatenation. You see no references to string.format. Now we see this thing called a default interpolated string handler. And this default interpolated string handler is what the C# compiler, by default, will use behind the scenes. And it's got these methods hanging off of it, like append literal and append format. And the append literal, as you can clearly see here, is the literal string. And the append formatted is the variable value. So there's the variable value, then the word at, and the variable value, and even the little period right at the end, the period that ended our sentence of our log statement. Okay, almost looks a little bit like string builder, but it's the default interpolated string handler. So the default interpolated string handler gives some efficiency right out of the bat because it is optimized. It uses the span of char internally and it's memory optimized compared to a traditional array, which a string builder is using a traditional array behind the scenes without having to resort to redimensioning of arrays and unsafe code blocks and things like that. Okay, so with that being said, we are going to implement our own string interpolation to take full control over our own string concatenation here. Okay, so let's keep going, and we're going. And I see there's a question about heap allocation for old string. That may have been. I'm not sure at what point that question came in. Oh, it looks like it just came in. Is that so, Lee? You're asking this question. Let me pause for your question here. You're asking about extra heap allocation versus the old concatenation. Are you talking about the string.format versus the straight up concatenation with the plus sign?
Yeah, the straight up concatenation doesn't actually allocate to the heap, right? And when you have that new object, you've got a new. Anytime you see a new, that's an extra heap allocation. Seems like is it actually improving performance?
It does, because it's going to allocate to the heap because the string is a reference type, so it's naturally going to be put on the heap as all reference types will be put on the heap. What they discovered though was with small allocations like that. Normally, if you're doing 100 concatenations in a row, the string builder is the thing that's going to have the increased efficiency. But when you're doing a small allocation, the performance is actually going to be much quicker with straight up string concatenation, which is why you see that. The string.format in that second example I showed was more about the fact that sometimes when it's not a string, you actually need to format the value. It could be you're formatting a date, it could be you're formatting an integer. And so the string.format was a safer display output there. Okay, so what I'm going to do is I'm going to get into some more of these examples. I'm going to set this aside. So I'm going to take this, and we're just going to put a little region at the end called set aside. And I'm going to just call initial demo. And I'm just putting this here so I can stick this here, set it off to the side. I don't want to delete code because of those of you that are going to download this, I want you to be able to recreate it. But I want to kind of clear my code space here. Okay, so I'm going to add a new file called logger.cs. And in this file, I'll just put some initial code here. You're going to see that I have a logger class right here. It's got a constructor, which is going to take a log level. The log level is kind of the traditional stuff we're used to seeing, none, error, warning, info. And it's got a log method here that says, hey, log this message right here. But first do this if statement to check. If the level is less than or equal to the current level, yeah, then go ahead and log it. Otherwise, don't even worry about logging it. Very traditional sort of paradigm here. So we're putting those initial statements in. And what you can see here is I'm instantiating the logger at the info message. I have 3 error messages here, my cool info, cool warning, cool error. And you can see I have different sets for each one. Because I'm on info, all 3 of these should log. Let me prove that to you. And sure enough, we have all 3 that have logged: info, error, and warning. Okay, good. Let's say if we set this to warning, the info message should no longer be logging, only warning and error, because that if statement will suppress us writing the info message. And sure enough, if we come in here and make this error, you know what will happen here, which is the info and the warning log messages will be suppressed, and we will only get that one message for the error message. So efficiency in our logging. Okay. That's all well and good, but if we think about what's happening here, we want to take a little bit more control over this, because even though, for example, when I set it to error, these aren't logging out anymore, we still have all this string concatenation is still happening. So it's still happening, and we want to take control over not only how, we want to take control over how string concatenation is happening and when string concatenation happens. So let's take the first question first: how string concatenation happens. Maybe we want to be the ones to take full control over. Are we using string.format? Are we using +++? Are we using a string builder? Are we using span of char? And we decide that we want to take full control in our code over how that string concatenation is going to happen. And the way we can do that in C#10 is to use an interpolated string handler. I'm just going to put the message right here: interpolated string handler. So when we dive into this, what you're going to see is that the interpolated string handler, this is the thing and I've called this log interpolated string handler. So this is my custom interpolated string handler, which I'm saying I just created this name right here, log interpolated string handler. And we are going to use this to help the framework decide how that concatenation is going to happen. And we are going to put this right on the message here. So instead of string, we're going to say this is of type log interpolated string message. And then down here, notice I'm getting a red squiggle on line 16. So I got to call get text, because that get text message is what I did right here. And effectively what's happening when you look at the code that I put in this particular log interpolated string handler is I'm internally keeping track of a string builder. I have this append literal and append formatted, because that is the contract that we must use to use an interpolated string handler. Keep in mind, those are the exact method names I showed you in IL-SPY a few minutes ago. And the other interesting thing is, by default, the interpolated string handler must have a constructor that has 2 integer arguments, one for literal length and one for format count. I'm just outputting what they are. And again, I can take control of how I want that concatenation to happen. So in this case, I'm just using string builder, append. But again, it's my choice. I could use span of char, or whatever the case may be. I could just do a bunch of plus operations. But this is enabling me to determine how that string concatenation is going to happen. So the code still runs the same. If we look at the output message, I'm still getting my cool error message, and only the error message is being logged. However, when we look at these other statements here, you can see the console statements here. These 4 statements were the result of my info message. Didn't get logged, but all the messages kept getting, all the concatenation still happened. These 4 messages here, these were from the warning. So here's the info message, here's the warning message. You can even see the number of characters here is 24, the number of characters here is 27, because the word warning is, and then here's the one right here for error message. So we have taken control over how string concatenations happen. We said, you know what, we want our string concatenation to happen with string builder, right? Or again, it might be, it's your choice. Maybe it's span of char, whatever the case may happen. But now I want to go to the second aspect of that, which is we want to take control over when string concatenation is going to happen. Because if you look at this, the obvious thing you say to yourself is like, well, I know if this is the only thing that got output, I don't really want to go through all of the mess of like doing all this string concatenation here, because this is allocations in memory every time I do a string concatenation. So I don't really want that to happen. Good that I'm suppressing the log message, but it'd be even better if I just suppressed all that work from having to happen. So how do we expand this to make that happen? So we're going to do a couple of things here. Number one, for my log interpolated string handler, I'm going to add a private member here called enable. And then what I'm going to do, and you can see it's giving me the red squiggle because since it's a struct, all members must be fully assigned. So we're going to come in here, instead of making this an expression body member, let's just do traditional curly braces here. Let's move this up into a constructor. And I'm going to make sure this is assigned. And the other thing I'm going to do is I'm going to add some additional parameters to this. So the first one is going to be logger. And then the second one is going to be log level, which we're going to call this level. And then in order to set the enabled property, we're going to say this.enabled equals, and this is going to be level. If level is less than or equal to logger.current level, then enabled is true. Otherwise, the enabled property is going to be false. Now, with that in place, this enables us to come over here and say, if not enabled, return. If we do that, we can do the same thing on this one right here. Okay. Now, a couple of magical things that just happened here that I want to explain so I can demystify them a little bit. Number one, if we look at this, I'm going to just make this a little bit lower so you can see what's happening here. This interpolated string handler is being used right down here. And I said that the rules by default are that the constructor must have these two arguments, two integers, literal length and formatted count. But I just added two additional parameters. How the heck does it know how to populate these two things? It's just a method, it's just the type that's on a method argument here. So we have to have some way to let it know how to populate these things. In order to do that, you have to use an interpolated string handler argument. I'm going to give this two parameters here, and let me make sure I'm very precise about how explaining what is going on here. When you specify an empty string, it's referring to the this pointer of whatever the most current thing is. So in this case, empty string means the current instance of the logger itself. Now, if you actually have a string populated in here, it must refer to some method parameter, which in this case is this. And you have to spell it exactly the same. If this is L-E-V-E-L, then this must be L-E-V-E-L. That must match. And so we know what these are. So in that case, this first one, that's the logger, right? So it's pointing to this. And this right here is the log level. That's pointing to this. So this interpolated string handler argument attribute is the thing that says, this is a custom log interpolated string handler. And I just gave a couple of these two extra parameters here that you don't know about by default. You have to have some way to know how to pass the correct values to this method. This attribute is the thing that tells you what to pass. So for the first argument, empty string, it's going to pass the current instance of the logger. The second one, level, it's going to take this value here and pass it in. And it's all going to be resolved right here. Okay. So now that we have these two things in here, what can we do with that? So what we can do is this. And by the way, let's make sure this is still running and doing exactly what we want. And sure enough, not only that, but look, we're no longer getting all those outputs from the info message and the warning message. Now we're only getting the outputs from the error message. And this is definitely a step in the right direction, because now I'm not going through all the extra string concatenations and memory allocations when I do the info and logging. So already the code is way more efficient now. However, I do want to point out one thing. The reason we're getting away with that is because this line number 50 right here is enabled true return, and same thing up here. That's still getting hit. I'm going to prove it to you. I'm going to hit, instead of control F5, I'm going to do regular F5. So we do it with debugging. So it forces me to hit these breakpoints here. I still hit the breakpoint 3 times. So here's the first time I just hit it. It's false. Let me continue. All right, I just hit it a second time. Let me continue again. Okay, I just hit it the third time, and then I continue again, and then the program will be done. So because we had these if statements in here, we were able to sort of trap the condition and stop it from coming in and doing, the string concatenation append here. So that's good. We got that efficiency. But wouldn't it have been even nicer if I didn't have to write these if statements? Leading question, right? And so, yes, so there's another way the log interpolated string handlers enable you to do even that. And the other rule is this: if as your last parameter you have an out variable that's a Boolean variable, you can call it whatever you want. I'm going to call it is enabled. What it allows you to do is something like this, where I can say is enabled, that out variable, let's just set it equal to this dot enabled. And in that case, it won't even bother to hit it. Let me prove that to you. Now, in this case, it says, oh, well, you're the error warning. So if it's info, I'm not even going to worry about it. And now I'm going to prove to you that this breakpoint is only hit 1 time. So let's run it again. F5, regular F5, not control F5. There I just hit my breakpoint 1 time. I hit the continue button, and we're done. So now I just got a lot of efficiency because I didn't even go into the method at all. So that means if I'm not going into the method, I don't even need these if statements anymore. And I certainly don't need the console write lines. I'm just doing those to illustrate the point. So this append literal just needs this 1 line. And this append formatted just really needs this 1 line. So we can simplify these 2 methods just by doing expression body members just like that. There's my append. And in fact, even this constructor up here, I could just say, oh, let's put this equal to this. We don't need this dot enabled. We can just set it equal to right there. We don't need that line. We don't need that line. We don't need this line anymore. And now we are just fully assigned. We can even make this an expression body member just for fun and get rid of some curly braces. Okay, yep, good. And now we've got even a simpler interpolated string handler. Everything runs exactly as we expect, no differences from before. And let me come back here. Yep, and there we go. All the console statements are gone, and it's not doing any extra string concatenation that we didn't want to happen. Those info, the warning, no string concatenation happened. In fact, those methods aren't even being entered into. I didn't even need to put if statements there because of my is enabled true. And so we get a lot of efficiency in what we're doing here. So again, I know we deep dive pretty far into this, but this, and a lot of the times when what you're doing, you can just use the default string interpolation. But when you find yourself in a situation where, oh, I really want to take full control over how string concatenation is going to happen and when string concatenation is going to happen, these are features you now have available in C# 10 that you can take advantage of should you ever want to take that control. Okay, so I'm going to set these aside. And again, just for those of you that download the code sample, this is going to be the logging demo. I guess I should really call that the string interpolation demo, but anyway, you know what I'm doing there. Okay, let's go on to the next feature. I'm not seeing any questions, so we'll go on to the next feature. Okay, so I'm going to come back here to the person class here. There's technically a person record, right? But a record is a class. A record is a reference type stored on the heap. And in here, I am going to override. And actually, let's actually run this first. I'm going to come in here and let's add Steve McLeody with this address. And we'll just say person to string, and let's run it to show what it looks like. And this is the default toString method that you get with a record, which if you're doing debugging is actually really nice. There's first name, there's last name, there's address right here. So that's all good. But if I'm not doing debugging, maybe I actually want a nicer toString method than that. Okay. So let's come over here and override the toString method. And we're just going to do kind of the standard string interpolation here, where we say first name and then a space and then last name. And now when we run it, the toString method will say, oh, okay, I'll just give you the nice little formatted Steve space Michelotti. All good. Okay, so nothing interesting about that. That's no C#10 specific features. Okay, now let's say that we want to have a subclass of this. So for example, let's say we have public record business contacts, and this is going to have a first name, a last name, and let's say in addition to first name and last name, we have a company name. And it's going to inherit from the person record. So we'll just pass in first name, last name, address to here. Okay, all good. And now when we come in here, let's create a business contact. And this will be Bill Gates, and the company name will be Microsoft. And then we'll just leave null for the address. And toString method on this. Now, when we run it, what we're going to see is, well, we already got this nice string override toString method here, but then for the business contact, we kind of went back to this default kind of first name, last name, every property. Again, the thing that good for debugging, but maybe we wanted this nice little override on toString to be on the subclass as well, and we don't have that anymore. So now in C#9 and before, you were just kind of out of luck in this case. But with C#10, what you can do is you can say sealed override, meaning prevent anyone else from overriding this. And when you do that, now the subclass gets the nice little toString override that you did on the base class. And this is a new feature of C#10, which is basically just seal the toString method of on records specifically. Because remember, records are essentially auto-generated types. C# compiler will generate those for you. And in C#9, you were kind of out of luck. If you wanted this, you had to do that override toString on every subclass. But now you can seal it on the base class, and it will use that implementation for the subclasses. Life-changing? No. Nice to have? Yes. Okay, so let's keep going here. Next thing, I'm going to add a new class. Let's call this extensions.cs. Kind of every project has to have a class called extensions, right? Let's do our namespace so we don't need all the indentation. Let's get rid of our using statements here. And I'm going to create a method here called isMaryland, where we pass in a person object to the method. And if the state is Maryland, then it's all good. And this would work just fine in C#9. Let's actually run this here. So I'm going to come in here and let's just make sure this works. So we'll come in here and say is Maryland : and then I'll just say person.is Maryland. And we just want to verify the output is as we expect. Steve Michelotti, 123 Main Street. And sure enough, is Maryland is true. Okay, cool. So it's working, our baseline's working. Now, if we go back to this method, I'm going to copy this line of code and actually comment it out because I don't want to delete it because I want you to go back and see what it looked like before. When you look at these property patterns right here that we've had in previous versions of C#, I mean, these are kind of nice, but at the same time, they can get a little confusing at times because you have a person that has an address object and the address object has a state property. And you have these curly braces that get inserted that feel a little unnatural. And you've got to do like multiple curly braces at the end to kind of make sure you're keeping track of your hierarchy. And so the syntax was sometimes not always pleasing for people. So wouldn't it be nice if you could just do address dot state and not have to worry about a curly brace hierarchy at the end when you have to close? Let's just get rid of that. And now in C#10, this just works. So this is called the extended property pattern. And when I run it, it works just the same as it does here. Is Maryland is still true. And what's nice about this, usually the first question is, yes, but what if the address object is null? Are you going to get a null reference exception? The answer is no, because the C# compiler defensively makes sure that the code is generating is defensive as it comes to null object. So if the address object itself is null, well, is null equal to Maryland? No, it's not. So that would return false. So that's another nice kind of nice feature of the extended property pattern, which is it defensively works just fine for null variable situations. Okay, let's keep moving. So we are starting to slide into the home stretch a little bit here. So I'm going to generate another method here on my extensions class, and we're going to call this isValidName, and returning a Boolean true false. And this is super rudimentary. We're passing in a string called name, and if the name is at least 2 characters, then we're saying it's valid, otherwise it's not valid. And I'm just putting a little console write line as to what happened there. And let's look at a few different variations. So when I look at these 4 lines right here, I have this first name valid. Is this constant string? Is this a valid name? Is this concatenated string? Is that valid? Is this interpolated string? Is that valid? Well, we know all 4 of these are going to be valid because they're all more than 2 characters, but let's just prove that to ourselves real quick. And sure enough, all of these 4 are valid. The first 2 are Steve, the last 2 are Steve McCloty. Okay, good to go. Now, if we come in here, it would be nice to have just a little bit more information about the variable being passed in. So what we can now do with C#10 is we have an attribute called caller argument expression. With a caller argument expression, I'm going to give it the name property, and then we're going to give it a variable, and we can call this variable whatever we want. Let's call it name expression. I'm going to set it equal to null, meaning it's a nullable parameter. It's an optional parameter. We don't have to send it in. In fact, we're not going to send it in. This string that we specify here must match to a parameter name, which in this case, you can see those match exactly. You must spell it. If it's NAME, this must be NAME. You've got to make sure that matches. And what is it passing in exactly? So let me just console write line that. And so you can see what this looks like. So I'm going to just say name of, and this is going to be just the name expression. We'll just say colon, name expression. Okay. Now we run this. Look at what happens. Of course, all 4 are still going to be true. The name expression of this was Steve. There was this hard-coded value that got passed in. In this case, there was a person.first name as well got passed in. In this case, it was a string concatenation that got pushed in. In this case, it was string interpolation. I mean, how many times have you been debugging a method in C# and you're like, well, I'm getting a null reference exception. I have no idea what they tried to pass in. Were they trying to pass in string concatenation? Were they trying to, or this is valid? Well, what was valid? Was it string concatenation? Was it a number? Was it a constant? Was it a variable? Here you can see exactly what the caller was passing in. In fact, this is something that even the framework is starting to take advantage of in the actual framework itself. So if I come in here and say argument null exception, there's this new method called throw if null, and I can just pass it this variable here called name. And let me show you what happens when I do that. I'll just say var p2, and that's a record. So we'll just say person with, we're going to take a copy of that first person object, but we're going to say where first name equals null, just to make sure we have some kind of null value there. P2 first name is valid name. Okay. And then when we run it, what we're going to see is the argument null exception. I didn't actually have to pass the string name into that. I passed the variable name, not the string name, but the framework now is smart enough to see, oh, that variable was called NAME, whereas previously it would have just had the value of the variable, not the name of the variable. We would have had to explicitly like use the name of operator, but we couldn't do it inside the method because by that point it's too late. We don't know what was actually passed in. And so those are just some interesting metadata scenarios that are nice to have to allow us to take control over the code till we have more sort of signals as to what's going on. And you can see here with the argument null exception throw if null, even the framework authors are using those in their own code as well. Okay, so we are going to set aside all of this, and I'm going to call this the caller expression attribute. Caller expression attribute demo. Okay, now let's keep going. A couple more features left. Some Lambda improvements. So when I look at this, this line would work before C#10. We're defining a func here called isEven, and then we just here have the Lambda body here, and then we call this function isEven, sending in 21. We know 21 is not an even number, so that should return false. Let's run this to prove it to ourselves, and sure enough, that returns false. This will work just fine before C#10. Now I'm going to copy this and comment it out and paste it again right here. What we can now do in C#10 is we can use the var keyword here. And this is inferred natural type on Lambda. Specifically, the var is what's giving it to us. Now, the compiler wasn't sophisticated enough in C#9 and before, so this wouldn't work. This would be a compile error, but now that just works. It's smart enough now to infer the type. It knows that what that is, that's going to be an integer and a Boolean right here. It sees that, integer and Boolean. C# compiler, that was just beyond its limitations in before C#10. So that's a new feature. The other thing is, like, let's say you wanted to put an attribute on Lambda parameter. I'm just going to put like the pure attribute here, and this just inserted a namespace. I don't want to muddy up my code here, so normally I wouldn't put this as a global namespace. Just for the purpose of the demo, I'm going to put it there so it gets it out of the way. And before, you couldn't put attributes on Lambda parameters. So again, that's one of those things where it's like, you would think that would have worked. And yeah, there's no reason that shouldn't have worked. It didn't, though. And now they've just, the language designers have fixed it. So the scenarios that you were like scratching your head, why didn't this work before? This should work. They probably just didn't have time to get it in before the deadline of C#9. Now that just works. Just a little bit further, if I come in here and say console.read, and I'm not going to have the parentheses, so this is just a method group when I'm referring to the method itself, like a pointer to the method. This is successful inference because there's only one overload, so this works fine. But if I was going to have a method group, console write, this not infer because multiple overloads. And you can see I'm getting my red squiggle there. It won't work. So that I have to comment out because that works. So again, just making sure you know the rules there. But this one does work. And this is another C#10 feature, which is inference for method groups. Again, method groups, we're talking about just assigning the method name to this variable. And then we could theoretically come in here and call it like this, ABC. Again, another C#10 feature that you may have been confused. Why doesn't this work in earlier versions of C#? So these are just little, it's like Lambdas didn't have quite parity with regular functions and regular methods. And a lot of these features are just getting Lambdas better parity with what normal C# methods would have. And same with this last example. So let's say I create I'm going to put a function pointer here called choose, and we're going to assign this a Lambda B, and we're going to say goes to, and I'm just going to put a little ternary here. If B is true, then return 21. Otherwise, return ABC. And if I console write line out there, I want to call my choose method, and I'll pass a Boolean of true in there. Now you're noticing that line, it's giving me a red squiggle, and it's getting confused. And the reason is because it's looking at this and it's saying, well, 21 is an integer and ABC as a string, and this is, again, we're kind of hitting up against the limits of the C#10 inference engine. And we know we can look at that and say, well, if we go up the inheritance stack to the least common denominator, the first thing we're going to hit is system.object, but it can't quite go to system.object. However, we can now get a return type to a Lambda. Traditionally, it's all about inference when it comes to the return type of a Lambda, but now we can be super explicit and say, hey, the return type of this Lambda is going to be system.object. So again, this is a new feature of C#10, where this is a Lambda return type. Normally, you don't need this in Lambdas, but in this case, we want to be super explicit. And sure enough, now it's working. There's my 21 is being output because I sent in a true, If it's true, return 21. So Lambda return type, just like a normal method can have a return type, right? Lambdas, we've always relied on inference, but if you want to put a return type on Lambda, you have the flexibility to do that as well. Okay, so let's set this aside. This demo is going to be the Lambda enhancements. Hopefully I'm spelling this right, demo. Just set that aside down there. Okay, now, the last series of demos I want to show has to do with structs. So I'm going to flip over to one more slide on here, structs versus classes. A struct is a value type. It's stored on the stack. A class is a reference type. It's stored on the heap. A struct logically represents a single value. So for example, a date, an integer, those are common structs. Structs should be immutable. So an integer is always 4, is 4 is 4. If you want to say 4 plus 3 is 7, those are all new integers. 7 is a new integer. Instance size is less than 16 bytes is ideal for a struct. Ideally, you want structs to be short-lived, ideally like local variables and methods. You also have to think of boxing and unboxing considerations. So when generics, for example, was added to C#2 way back in whatever that was, 2005, was it? We didn't necessarily have any performance improvements for reference types, but we did have performance improvements for value types. So if we had an array list of integers, every time you put an integer onto an array list or got an integer off an array list, you were doing either a boxing or unboxing operation. It's added performance hit, it's added memory pressure, it's added cycles on the garbage collector, and so that's all bad. You don't have that same tax for reference types. So you have to think about like your scenario. Do you want reference types or do you want value types? And depending on what your scenario is, you want to be able to choose the correct choice between those two. Now, if you had seen me do a C#9 presentation when I introduced records, you would have heard me say multiple times, a record is a class. A record is therefore a value type, period, at the end, which is fine. But then if you had situations where you actually wanted to use the immutable semantics of a record, but you wanted a value type, you were kind of out of luck in you were out of luck in C#9. Now in C#10, we've got some enhancements, not only for that, but also to get the concept of structs to bring parity with better parity with structs up to the parity with classes. And so I'm going to illustrate a couple of these things. So I'm going to add a new class called point.cs. And what I'm going to do here is I'm going to, by default, it's making this a class. I'm going to make this a struct. So don't worry about records yet. First, let's just talk about classes and structs. And let's keep deleting all this stuff, and let's get rid of the indentation. And so what I'm going to do here with these points is let's just do an X and a Y coordinate, which is pretty logical for a point, right? And I'm going to come over here and we're going to set point P equals to new X is 2 and the Y is 4. And then we'll console write line P dot toString. And let's make sure I have that correct. Now, when we look at this, what I want to do is I want to generate a constructor here. So I'm going to come to the end and do control dot. And I'm going to, you can see right there, it says generate constructor. I'm going to do that. And it's smart enough to know that I have two properties. So it generates that constructor for X and Y. It's assigned to X and Y right there. And you can see I pass in 2 and 4 into the parameters here. And this is going to be exactly what you think. 2 and 4, and we're outputting the toString method right there. All good. Okay, now that is everything I could have done in C#9. But now let's think about C#10 a little bit here. So the first thing I'm going to do is I'm going to put a parameterless constructor like this. And you're going to see a couple of things right off the bat. Number one, notice that it's giving me a red squiggle. And it's because for structs, structs must be fully assigned. Otherwise, the compiler is not going to let you do this. So let's, a little bit contrived, but let's just assign X to 1 and let's assign Y to 1. And that is happy. Another thing to keep in mind is that this wasn't even available before C#10. So just the fact that we have a struct, let's spell it right, struct, parameter-less constructor, this code does not compile in C#9. You could not have a parameterless constructor in a struct prior to C#10. So just the fact that we could do this at all is a new thing in C#10. Now, let's actually go ahead and call this parameterless constructor. So let's say point P2 equals new, P2 to string. And in this case, you probably can guess what's going to be output here. And if I run it, you're going to see, yep, I had assigned 1 and 1 in that parameterless constructor. And so there you go. That works. Now, one other interesting thing here is if I comment out y right here, notice I'm going to get my red squiggle back because, again, a struct wants itself to be fully assigned. What I can now do is I could actually put this assignment down here if I wanted. And this is, again, a new feature in C#10 that was not supported before. Struct field initializer does not compile in C#9. And if you look at a lot of this stuff, you say to yourself, well, this doesn't seem like a big deal. Like I do this stuff in classes. Yeah, you're right. You could do it in classes always, but you could not do it in struct. So when you hear me say a lot of things in C#10 are just bringing the feature set of structs up to better parity with the feature set of classes, this is a good example of the types of things I'm talking about here. But it runs just the same. And there's my 1/1. So field initializer is still functionally the same thing as a constructor. Now, the last point here I want to show, just for illustration purposes, if I say point 3, P3, I'm going to use the default keyword of point, and let's output P3 to string. Now, not necessarily going to make people shout it out, but if you look at the line of code that I just put right here, I'm going to run this in a second, but before I do, I just want you to kind of mentally in your head ask yourself, what do you think the output is going to be here? And while you take 5 seconds to think about that, I'm going to run it. And what most people think the output is going to be, most people think the output is going to be 1 and 1, and they get very surprised to see this. I have not had anyone yet think to themselves, oh yeah, that's obviously going to be 0, 0. Because when people think of the default keyword, you're using the default for that type. But as it pertains to structs, the default keyword will not automatically run the default constructor of a struct. And because the struct had 2 integers and the default value of integers is 0, this was actually the output right here. Just something to be aware of, because that's definitely a gotcha that surprises people when they first think about these when you're using structs in C#10. And again, it's somewhat of an edge case, the default keyword with a struct that has a parameterless constructor, but something to definitely be aware of if you're using these things, because it's not what you would expect. Okay, now, a couple other things here as it pertains to structs. What I'm going to do here is I want to change this to a record, but what I'm going to do, I'm going to just rename this briefly called point struct. Because I renamed the struct, I got to rename the constructors. And I'm going to create a new thing called public record point. It's going to take an X and a Y. And then I'm just going to create a distance property. Distance, let's spell it right. And I'm just going to use a one-liner expression body member. I guess technically I should call this distance from origin, but there it is. There's the formula for distance from the origin. X squared plus y squared will give you the distance from the origin. Okay, and I'm gonna take these out because my record doesn't have a parameterless constructor anymore. So when I just use my first 1, 2, and 4, I'm gonna right line that here. What you're gonna see is we're back to, there's the point, X is 2, Y is 4. The distance formula right there from the origin is 4.4721, blah, blah, blah. Okay. Good to go. Now, why do I care about this? I want to show the enhancements they made to C#10 as it pertains to records, and specifically as it pertains to records deconstructors. So what I'm going to do is I'm going to put a few outputs here. And you're going to see that here we have, again, a deconstructor, not the same thing as a destructor, a deconstructor, where I can take a object, in this case, P is a point, and I can deconstruct, and these deconstructors are automatically generated. So here I declared them outside the deconstructor. I use them on line 11. On line 13, I'm declaring them in line. So the var keyword is here and here, so we're declaring them in line. And this works in C#9, and this works in C#9. So this is setting up our baseline, and let me just show you the output. Yes, it works. There's the deconstructor for 2 and for 4. All that works. Okay, so that all works in C#9. Now in C#10, what we can do is, let's say we have x2 and then var y3 equals p. And I'm just going to copy and paste this one here, and x2 is already there. Let's make this y3 and y3. What's different about this one is that in C#10, we now have the ability to mix the declaration and assignment in same deconstruction. And when we run it, it just works. Okay, there it goes. It just works. And let me just show this to you really quick, because I did this pretty quick. Here, this was consistent. X and Y were both declared before the deconstruction. I used them, X and Y, in the deconstruction. They're both declared in advance. Here, the declaration happened inside the deconstructor in line, var and var. So I was declaring x2 and I was declaring y2 at the same time of deconstruction. They were in line. I did not declare them in advance. It works in C#9 only if it's all or nothing. You either have to declare all your deconstruction variables in advance or all in line. Here you can see this x2, this one was declared in advance. In fact, it was declared up here on line 13. Whereas this one was declared in line right here on line 17. Again, a little bit of an edge case, I acknowledge. I'm simply the bearer of information here. This is an edge case that popped up a few times and people would get frustrated, like, why can't I do this? I should be able to do this. And so the C# designers just worked in C#10 to enable this. So this was no longer a limitation anymore. So this feature is the ability to mix declaration and assignment in the same deconstruction. Now, if I come back to the point class over here, let me close down ILSpy here. I'm going to right click this record for point, and I'm going to open this up in ILSpy. And this is a public record of point. And remember what I said before, a record is a class. So it's a reference type. So it's stored on the heap. And if I click point right here, I can see what was generated by C# record. Well, sure enough, it generated a class. So I proved it to you. It's a class, it's a reference type. Okay. What we can now do in C#10 is I can say record structs. So the new feature here is record structs. Let's do a quick build. And when I do that, just by putting the struct keyword after the record keyword, I'm going to come over here and refresh. Now what you're going to see is suddenly the point type is no longer a class. It's now a struct, which means it's now a value type, which means it's now stored on the stack. So previously, in C#10, we did not have the ability to control whether a record was going to be on the heap or the stack. It was always going to be on the heap. It's always going to be a reference type. Now in C#10, we have the ability to control that. If we want it to be a value type on the stack, we can now do that by calling it a record struct. And not only that, but we can also do this where if I come in here and say public void increment, and let's just put a one-liner here. Let's call this x plus plus. Okay, this is valid. This builds. It's valid. But the problem is, like, the whole point of records and structs really, you want these immutable semantics. And now I've just added this increment method that mutates the state of the X property. And that's really not in keeping with the spirit of what we're going for here with immutability and structs. So what we can now do in C#10 is I can even apply the read-only keyword to the record. And notice as soon as I did that, I've now got the red squiggle here saying, oh, this is a compile error. you're mutating the state, and you're not allowed to mutate the state on read only. So we can, and I'm going to add read only up here. And so that's a compiler error, so I can't do it. So I have to comment it out. And now once I comment it out, I can build it successfully. And let me refresh over here to show you the implications of that. It added the is read only attribute behind the scenes. So the compiler is going to enforce the no mutating of state. And so again, it's another nice to have to give you the control over the semantics in terms of where the memory is going to be and how you're going to deal with that object in terms of mutations and that kind of thing. Okay, I'm coming in, perfect timing here, 8 p.m. There was a couple other features that were added to C#10. These 5 were also. These were kind of edge cases though, so I didn't think they rose to the level of needing me to show you a code demo of these. However, these have links for each one. So for those of you that download the PowerPoint, in the next 24 hours or so, I will put a tweet out on Twitter with a link to the zip file where you can download all the code samples that I just showed and the PowerPoint. So you can click these links in the PowerPoint to get all of this. So we covered a lot. We covered global and implicit usings, file scope namespaces. We really did a deep dive into string interpolation and some of these nice to have, like the extended property pattern, a bunch of improvements on lambdas, a bunch of improvements on structs, regardless if you were doing standalone structs or structs with records, some deconstruction enhancements and that sort of thing. So we covered a lot of ground in that time. So I'm happy to stay on for any questions. Here's my contact info. So there's my Twitter handle at the end if anyone wants to watch out for the code samples, that I'll post a link. And again, my team at Microsoft is currently hiring, so also feel free to reach out to me if you want to know more about that. So with that, thanks everyone for attending. And like I said, I'm happy to stay on for questions, or you can always contact me later.
Hey, thank you, Steve. Awesome. So I don't know if your C#9 presentation is available online anywhere, but that was wonderful. So you might want to post that too if it's around somewhere, because I remember maybe you did it last year, and I just thought, wow, this is so cool. So
yeah, there might be a recording somewhere. I would have to check that. And even in the C#9 presentation, what I did was I actually covered a lot of the features in C#8 because sometimes those are easy to miss. So it might be around somewhere. I can look for that and see if it's posted. Certainly the code samples are up there, but I may have a video somewhere.
cool. So I'm gonna go ahead and stop the recording.
Yeah.